Making drastic changes in tuning to your drum samples is a classic and simple way to get experimental with your drum sounds. The tonal nature of 808 and 909 drum hits make them particularly good for this. Using an 808's toms as a simple bass pattern around a punchy kick is a tried and tested trick throughout the harder ends of house and techno. Separating the sounds onto their own tracks within a drum machine or DAW allows us to process them separately later on. Here we're using an 808 tom around a punchy 909 kick. We pitch the tom down 6 semitones to bring out its sub-frequencies and to suit the pitch of our track. It's worth experimenting with the tunings of other drum sounds though. Drastically pitching up or down things like snares, hats or percussion hits is a great way to change their texture, and combined with tweaks to the amp envelope and filter, it can turn simple drum sounds into something unique and different. Your DAW likely has plenty within its basic toolset that will allow you to turn a dry drum sound into something more futuristic or creative. Tools such as resonators, comb filters and ring modulators are great for this. Each can apply tunable, metallic or unnatural qualities that sound particularly great on kicks, snares and percussion. Let's try adding some ring modulation to a snare. Ableton's corpus effect is particularly good for this. This is a resonator effect that allows users to process sounds using physical modelling. The effect is tunable with decay controls, plus modulation and filtering. Try using it like this to add extra sub-frequencies below a kick. We can use the decay to control how boomy our kick is. Alternatively, we can create some weirder effects. By processing and modulating a percussion part. Finally, let's add a resonator to these hats. Here we're turning the classic hat sample into something more like a chord stab rhythm. This works particularly well with a bit of filter modulation. The most conventional approach to creating a beat is to sequence individual hits to create a rhythm. But an alternative approach is to start with a fuller block of sound and create our rhythm subtractively by carving space out of it using something like a gate or filter plugin. The key to making this work is to start with a long textural sound source. Something like a loop of white noise, a Foley recording, or even a heavily pitched down cymbal makes a great starting point. We can then use a gate or low pass filter to create a rhythmic effect, which we can control using something like a step sequencer, an LFO, or as we've done here, by drawing automation directly into our clip. This allows us to create a percussive effect while maintaining the texture of the original recording. Here we're engaging a filter to add some more rhythm to our beat. Delays are inherently percussive effects in that the spacing of their repeats always creates some form of rhythm. As well as adding character or space to drum hits, delay plugins can be used as effective rhythmic sequences in their own right. To start, create a simple pattern with just a few drum hits, each placed on its own track so that we can load a delay plugin after it. By engaging the delay and playing with things like timing, feedback and dry-wet controls, we can create an interesting rhythm from just these few simple hits. Try experimenting with things like filtered delays, pitch shifting delays, and layering up multiple instances of delay plugins. Once you've got a rhythm going, try modulating parameters as your track progresses. Probability-based sequencing is now an increasingly common MIDI tool in DAWs. It can be great for creating unpredictable variations, albeit ones that adhere to your own design. Let's try enhancing our beat here with a few unpredictable ghost notes and effects hits. This works particularly nicely when we're using some sparse hits fed into a long delay or reverb. Here we're going to pick a few simple basic hits and effects sounds and try triggering them over the beat we've already built. At the moment, all of these hits have 100% probability, meaning that they'll trigger every time the loop cycles. However, by decreasing that to something less than 100, we can randomize the amount of times that we'll hear each hit.